May 6, 1937, the massive airship Hindenburg bursts into flames in just 34 seconds. But what really happened? Was it just hydrogen? Or was there more at play? Let's break down the physics behind this disaster. The Hindenburg was a technological marvel over 800 feet long, filled with 7 million cubic feet of hydrogen, a gas that's 14 times lighter than air. Hydrogen made it float, but it also made it a fire hazard. Hydrogen is extremely flammable, but there's a catch: it doesn't just burn, it explodes. When mixed with oxygen, it forms a highly reactive combination that ignites almost instantly. A single spark can set off a chain reaction, causing the entire gas supply to combust in seconds. So, what ignited the fire? There are multiple theories, but the most likely culprit is static electricity. As the airship approached the landing zone, it had built up a massive electric charge from flying through the air. When the crew released landing ropes, they likely created a grounding effect, causing a spark to jump onto the flammable skin of the airship. Surprisingly, hydrogen may not have been the first thing to ignite. The outer fabric was coated with a mix of iron oxide and aluminum powder, a combination similar to thermite, which burns at over to 500 degrees Celsius. Once ignited, this highly flammable coating could have set off a runaway fire, spreading rapidly across the surface of the airship. The result, a fire that engulfed the entire structure in just half a minute. The heat from the burning outer skin and frame would have accelerated the hydrogen combustion, making escape nearly impossible. If the Hindenburg had been filled with helium instead of hydrogen, the disaster might never have happened. But at the time, the US had a monopoly on helium and refused to sell it to Germany. Today, airships use helium, which is completely non-flammable. The physics of the Hindenburg disaster taught the world a crucial lesson when designing technology. Understanding science isn't optional, it's essential. So, what do you think? Could this disaster have been avoided? Let me know in the comments, and if you enjoyed this breakdown, don't forget to like, subscribe, and hit that bell for more deep dives into the science behind history.